Hey everybody, Daniel here from Basement Tech. Welcome to a series of videos covering conversion of the CNC Shark CNC wood cutting router behind me from its proprietary controller to one based on LinuxCNC. Well, why convert from the proprietary controller to a LinuxCNC based system? Well, I have a couple ideas in mind. Number one, I wanted to create a more open system for experimentation and research. The proprietary controller that comes with these machines is really buttoned up, so much so that it's even hard to add limit switches, for example. So the ability to add limit switches and control other accessory devices through one controller is really a second goal of mine. Thirdly, I just wanted to have a machine here at home. And fourth, I really just want to make things. Well, let's start off. Let's see, I'll give you a quick tour of the configuration I put together just to demonstrate feasibility. You're going to see a lot of things wrong with this system, and I'll try to mention them as they go by. And those will be the topics of the videos that are coming up. All right, well, let's get on with the grand tour of this, which is the feasibility demonstration configuration that I put together. You can see the machine itself, call it a manipulator, a Cartesian robot, or a gantry, is the Next Wave Automation CNC Shark. Honestly, I'm not sure which model number this is. I was trying to figure that out from the website, but couldn't. It has a bed of about 24 by 24 and X, Y, and Z axes. Typically, you'll see these with a commercial router like this mounted up to them, and they're useful for carving interesting shapes into wood. On this gantry, there are stepper motors, one for X, one for Y, and one for Z up here. Those stepper motor signals are supplied by these cables, and this is going to be the first thing we change. These are wildly inadequate. It's what I had, and I'll cover near the end of this video the new cables that I bought and why. One reason why is I can actually sense, I can feel that these cables are above ambient temperature, which is disturbing to begin with, but okay for this quick feasibility system. So those cables run back to this G540, which was gifted to me by a very generous patron. I know that's a luxury for me to say because it's a very nice and somewhat expensive but very robust controller that a lot of people use. That controller is fed, sorry to make you a little bit dizzy, by this computer over here. Now, it's not by any means, an up-to-the-date something you would buy today computer, but it's got an Intel i7 computer, 16 gig of RAM, a little bit of a graphics card, but maybe more importantly, down at the bottom, it has the Mesa, let's see, what is that card? It's the 5i25 card. It supplies to the operating system a little easier way to talk to the parallel port, which drives the Gecko G540 through that DB25 rather hefty cable there at the bottom. Those are low level signals, not high current signals, so this is completely adequate. Now zooming back out, this is the screen, which is LinuxCNC. It's really pretty cool. I can cover how I loaded up this operating system, configured it for this particular set of hardware in an upcoming video, but all I wanted to do here was show you, just like Mach 3 does in the machines down at the shop, you push the buttons on the keyboard and the axes move. That's the demonstration that I wanted to do here. Could I put together a set of components, very loosely in this case, that would actually generate motion based on commands from the keyboard? So I'm going to say feasibility, check. Well, hey, I decided not to pack too much into this video, so I'll end this introduction/feasibility video here with just a short list of things I intend to do next. Number one, as I mentioned, I'll give you a little bit of a review and talk about the new motor cables that I bought. They're DB9s on each end, but have way heftier conductors. So I'll give you a little bit of a dissection and review on those cables. Secondly, I am going to implement limit switches, both mechanical and inductive proximity-based limit switches on this specific machine behind me. So if you have the same machine, this could be useful to you in implementing limit switches on your machine. Thirdly, this feasibility system is using a 24 volt power supply. I'll probably upgrade that to a 48 volt power supply, which generally provides a little bit more nimble response to the commands from the LinuxCNC. After that, we'll see where it takes us. I do happen to have a 2-watt blue laser that I know will make wood smoke if you aim it at it, so I may mount that up and see if I can do some wood engraving using this machine. Anyway, lots of possibilities, and that's what this machine is designed to do. Have fun and learn. I hope you like this video, and I hope you like the upcoming videos. If you have a machine like this, please comment about your experience with this machine and whether this conversion is something you might like to do. If you have questions, put those in the comments. Even simple questions. I've worked through the process of converting several machines, not CNC Sharks in particular, but building and converting several CNC machines. So not that I'm the world's expert, but I do have some experience, and I might be able to help out with some of your questions. I will either point you to or do a video on loading Linux CNC onto a computer and configuring it for this specific configuration. There are a lot of good videos that already exist on that topic, but if I can't find one that's specific enough for this machine, I'll do one of my own. If you like this video, please give it a thumbs up and stay tuned for the rest of the videos. If you really like this kind of video and the kind of things you see on my channel, subscribe and hit the notify me when new videos arrive button so that you never miss a video. Thanks, we'll talk to you soon.